Yes, when electricians cut threads on rigid conduit, it is supposed to have a taper to the threads. This is a requirement of the National Electrical Code. NEC Article 344.50 states threaded joints shall be made up with threads fully engaged and a minimum of 5 full threads in engagement. NEC Article 344.52 states threaded conduit shall be installed so that the conduit threads are fully engaged and the ends of the conduit are in contact. Tapered threads help to create a tight seal between the conduit and the fitting. This is important for preventing electrical shorts and fires. Plumbers also use tapered threads on their pipes, but the taper on their threads is different than the taper on electrical conduit threads. The taper on electrical conduit threads is 3/4 inch per foot. The taper on plumbing pipe threads is 1/16 inch per foot. This difference in taper is why you cannot use plumbing fittings on electrical conduit, and vice versa. The purpose of tapered threads is to create a secure, leak-proof, and electrically continuous connection. This is achieved through the wedging action of the tapered threads as they are tightened together. The tighter the connection, the better the seal and electrical conductivity. Using the correct type of thread sealant or pipe dope is also crucial for ensuring a proper seal, preventing corrosion, and facilitating future disassembly if needed. Thread sealants fill any microscopic gaps in the threads, further enhancing the connection's integrity. When threading rigid conduit, it is essential to use the right tools and techniques to create clean, consistent threads. This includes using a sharp threading die, applying cutting oil to lubricate the die and conduit, and maintaining proper alignment throughout the threading process. Imperfect threads can compromise the connection and increase the risk of failure. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect advancements in technology and best practices. Compliance with the NEC is essential for ensuring the safety of electrical systems and preventing hazards. Rigid metal conduit, or RMC, is a type of electrical conduit that is commonly used in industrial and commercial applications. It is made of thick-walled steel or aluminum and provides excellent protection for electrical wiring. RMC is typically used in locations where wiring is exposed to physical damage or corrosive environments. Intermediate metal conduit, or IMC, is another type of electrical conduit that is similar to RMC but has a thinner wall. IMC is lighter and easier to work with than RMC, but it provides less protection for electrical wiring. Electrical metallic tubing, or EMT, is a thin-walled conduit that is commonly used in residential and light commercial applications. EMTs are easy to bend and cut, making it a popular choice for many electrical installations. Liquid-type flexible metal conduit, or LFMC, is a flexible conduit that is designed to be watertight. LFMC is used in applications where wiring is exposed to moisture or other liquids. Firstly, understand the different types of conduit. Secondly, know the specific NEC requirements for each type of conduit. Thirdly, use the correct tools and techniques for cutting and threading conduit. Fourthly, apply thread sealant or pipe dope to ensure a proper seal. Fifthly, inspect the completed connection to verify that it is tight and secure. The NEC specifies the minimum number of threads that must be engaged in a threaded connection. This requirement is intended to ensure that the connection is strong enough to withstand mechanical stress and vibration. The use of thread sealant or pipe dope can also help to improve the strength and integrity of threaded connections. It is important to select a thread sealant or pipe dope that is compatible with the conduit material and the environment in which it will be used. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements must be followed carefully to ensure the safety of people and property. Conduit bodies are fittings that are used to provide access to the interior of a conduit run. They are available in a variety of shapes and sizes and can be used to make bends, splices, and terminations. Conduit bodies must be properly grounded and bonded to ensure electrical safety. Lock nuts and bushings are used to secure conduit to boxes and enclosures. Lock nuts are used on the outside of the box or enclosure, while bushings are used on the inside. Both lock nuts and bushings must be properly tightened to ensure a secure connection. Connectors are used to connect conduit to other components, such as boxes, enclosures, and equipment. Connectors are available in a variety of types, including threaded, threadless, and compression connectors. The type of connector that is used will depend on the type of conduit and the application. The NEC requires that all electrical equipment be listed by a recognized testing laboratory. Listing ensures that the equipment has been tested and found to be safe for its intended use. When selecting electrical equipment, it is important to look for the listing mark of a recognized testing laboratory, such as Underwriters Laboratories, or UL, or Electrical Testing Laboratories, or ETL. Electrical work should only be performed by qualified electricians who have the knowledge and experience to do the job safely. The electricians must be licensed and insured to protect themselves and their customers. When hiring an electrician, it is important to check their credentials and references. Continuous learning is essential for electricians to stay up to date on the latest codes, standards, and technologies. The electricians should participate in continuing education courses and workshops to enhance their skills and knowledge. Many organizations offer continuing education opportunities for electricians, such as the Independent Electrical Contractors, or IC, and the National Electrical Contractors Association, or NEC. Electrical safety is everyone's responsibility. Homeowners and business owners should be aware of the potential hazards of electricity and take steps to prevent accidents. This includes keeping electrical equipment in good repair, avoiding overloading circuits, and never working on electrical equipment while it is energized. Firstly, ensure that you are properly trained and qualified to perform electrical work. Secondly, always disconnect power before working on electrical equipment. Thirdly, use the correct tools and equipment for the job. Fourthly, follow all applicable codes and standards. Fifthly, inspect your work carefully before energizing the circuit. Conduit bending is a skill that is essential for electricians. Conduit must be bent to fit around obstacles and to make connections to boxes and enclosures. There are a variety of tools and techniques that can be used to bend conduit, including hand benders, hydraulic benders, and electric benders. The NEC specifies the minimum bending radius for conduit. This requirement is intended to prevent damage to the conduit and the conductors inside. The bending radius will depend on the size and type of conduit. Proper planning is essential for any electrical installation. Before starting work, it is important to develop a detailed plan that includes the layout of the wiring, the location of boxes and enclosures, and the type of conduit and wiring to be used. A well-developed plan will help to ensure that the installation is done safely and efficiently. Troubleshooting electrical problems requires a systematic approach. The first step is to identify the problem. The second step is to gather information about the problem. The third step is to analyze the information and develop a hypothesis about the cause of the problem. The fourth step is to test the hypothesis. The fifth step is to repair the problem. Electrical testing is an important part of electrical work. Electrical testing is used to verify that electrical equipment is functioning properly and to identify potential problems. There are a variety of electrical testing tools available, including multimeters, clamp meters, and insulation resistance testers. The NEC requires that certain electrical tests be performed on new and existing electrical installations. These tests are intended to ensure the safety of the electrical system. Preventive maintenance is essential for keeping electrical equipment in good working order. Preventive maintenance includes inspecting equipment regularly, cleaning equipment, and lubricating moving parts. Preventive maintenance can help to prevent breakdowns and extend the life of electrical equipment. Energy efficiency is an important consideration in electrical design and installation. There are a variety of ways to improve the energy efficiency of electrical systems, such as using energy-efficient lighting, installing occupancy sensors, and using variable frequency drivers on motors. The NEC includes requirements for energy-efficient electrical design and installation. Sustainable electrical practices are becoming increasingly important. Sustainable electrical practices include using renewable energy sources, such as solar and wind power, and reducing the use of hazardous materials. The NEC includes requirements for sustainable electrical design and installation. Firstly, understand the principles of electricity. Secondly, know the NEC requirements for electrical installations. Thirdly, use the correct tools and techniques for electrical work. Fourthly, follow all safety precautions. Fifthly, continue to learn and improve your skills. When working with electricity, it is essential to be aware of the potential hazards. Electrical shock can cause serious injury or death. Electrical fires can cause significant property damage. Always take precautions to protect yourself from electrical hazards. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated footwear. Avoid working on electrical equipment while it is wet. Never overload circuits. The NEC provides specific requirements for working safely with electricity. These requirements must be followed carefully to prevent accidents. Understanding overcurrent protection is important. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip, interrupting the flow of current and preventing damage to the circuit. The NEC specifies the type and size of overcurrent protection devices that must be used in electrical installations. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the current if a ground fault is detected. Ground faults occur where electricity flows through an unintended path to ground, such as through a person's body. The NEC requires GFCIs to be installed in certain locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are devices that are designed to protect against electrical fires. FSIs monitor the current flowing in a circuit and quickly interrupt the current if an arc fault is detected. Arc faults are dangerous electrical discharges that can ignite flammable materials. The NEC requires FSIs to be installed in certain locations, such as bedrooms and living rooms. Surge protection devices are designed to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy sensitive electronic equipment. Surge protection devices divert the excess voltage to ground, protecting the equipment from damage. The NEC includes requirements for surge protection in certain applications. Understanding bonding and grounding, as stated before, are critical for electrical safety. Bonding ensures that all metal parts of an electrical system are electrically connected, creating a low impedance path for fault current. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC provides detailed requirements for bonding and grounding electrical systems. Understanding the color codes for electrical wiring is crucial for safety and proper installation. The NEC specifies the color codes for electrical wiring. These color codes are used to identify the different conductors in a circuit, such as the hot conductor, the neutral conductor, and the ground conductor. Following the color codes helps to prevent accidental connections and ensures that the circuit is wired correctly. Black typically indicates the hot conductor. White typically indicates the neutral conductor. Green or bare copper typically indicates the ground conductor. The NEC specifies the allowable ampacity of conductors. Ampacity is the maximum amount of current that a conductor can carry safely without overheating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. The NEC provides tables that list the allowable ampacities of different types of conductors. Understanding voltage drop is crucial in electrical installations. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail. The NEC recommends limiting voltage drop to a certain percentage of the source voltage. Calculations are necessary to determine the voltage drop in a circuit. Understanding transformers is important for many electrical applications. Transformers are used to step up or step down voltage levels. They are commonly used to supply power to buildings and equipment. The NEC includes requirements for the installation and protection of transformers. Understanding motors is important for many electrical applications. Motors are used to power a wide variety of equipment. The NEC includes requirements for the installation and protection of motors. Understanding lighting is essential for providing adequate illumination in buildings and outdoor areas. The NEC includes requirements for the design and installation of lighting systems. Understanding the specifics of wiring methods is crucial to safety and compliance. The NEC specifies the allowable wiring methods for different types of electrical installations. Wiring methods include conduit, cable, and raceway. The choice of wiring method will depend on the application and the environment. Understanding the requirements for hazardous locations is important for electrical safety. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC includes special requirements for electrical equipment installed in hazardous locations.